Today we'll talk about what is integration and differentiation and their techniques and how is integration and differentiation used in pharmaceutical industry. This is the integration graph and the integral of the fx gives the area under the curve between those points.
Integration is a method of reversing the process of differentiation to find the original value. It is also mainly used to find the area under the curve. There are 6 integration techniques, namely simple integration, integrate with substitution, trigonometry integration, repeating partial integration, substitution that rationalize, and integrating powers. Slide 7 and 8, each technique has an example of question and its solutions. Note that when using the integrating powers, n in the formula must be equal to 2 or greater than 2. Otherwise, these techniques cannot be used to solve the question. So, you need to use other techniques to solve question when n is lower than 2.
What is differentiation? It is a process of finding the derivative or the rate of change in a function. It also can be used to find the gradient of a tangent in a curved line. So, the differentiation is to get rid of the negative value. So, as you can see the differentiation graph here, the fx dx, as you can see the curved line, the tangent line is x equal to a. There are 5 types of differentiation techniques, which are the chain rules, sum and difference rules, products, quotient, and power rules. So the chain rule, also known as the differentiation of a function in a function. So as you can see the equation here, the dy over dx is equal to dy over du times du over dx, while the sum and difference rule is the d over dx multiplied the u plus v, while the difference rule is the d over dx multiply u minus v. For the product rules, is the d multiply the u and v over the dx is equal to the u multiply the derivative v over dx plus v multiply du over dx. For the quotient rule is the v multiply du over dx minus u multiply dv over dx and over the v square. The last part will be the power rules, also can be like the power you times it in front and then the power will be minus 1.
Now we'll be talking about how integration and differentiation can be applied in the biotech industry. So the biotech that we have chosen is a drug dissolution machine. So how does it work? Dissolution is the process in which a substance forms a solution. So with dissolution in drugs, we can then gather the needed information to find a suitable drug for diseases. So moving on, very briefly, differentiation is used to find the concentration and rate of the solution of drugs. Then after that, we can use integration to find the total volume of drug that's absorbed by the human body at a certain time interval. And after that, we will have enough information to perform drug discovery to find the suitable medicine for our diseases and the suitable doses.
Derivatives are used in biology for several different purposes and can be used to find out the rate of muscle contraction, the rate of dissolution of drugs into the bloodstream, and the growth of bacteria. When a drug is administered to the body, it is dissolved into the bloodstream. The rate at which this occurs is known as dissolution. By using this rate, differential equations are used to relate the concentration of drugs at different times. This can be modeled using the Noyes-Whitney equation, dW dt equals to A times D over L times Cs minus C. dW dt is the rate of dissolution, A is the surface area of the solid, C is the concentration of the solid in the bulk dissolution medium, Cs is the concentration of the solid in the diffusion layer surrounding the solid, D is the diffusion coefficient, L is the diffusion layer thickness. By using the Noyes-Whitney equation, the rate at which the drug absorbs can be found as dW dt. In many cases, the rate of elimination of a drug can be described as being dependent on or proportional to the amount of drug remaining to be eliminated. Therefore, dx dt equals to negative k times x. Negative k would be the rate constant and x is the amount remaining to be eliminated, thus making dx dt the rate of elimination. After integrating this to find an original equation, the equation x equals to x naught times e to the power of negative kt can be used. Differentiating this equation using the given components can solve for the rate of elimination. This, in accordance with the rate of dissolution, can be used to find a drug's path in the body when administered.
Besides differentiation, integration is also used in biology. For example, the global warming, the sensitivity of drugs, voltage of brain neurons, the dispersal of seeds in an environment, and the average rate of blood flow in the body. Let's move back to drug dissolution. Now that we can solve the rate of dissolution of a drug into the bloodstream, we can use this to find the total amount of drug being absorbed. Say a drug absorbs into the bloodstream at the equation modeled by R equals to 3m squared over m cubed plus 1, where m represents the dosage. We can then find the total amount of drug absorbed into the bloodstream over a given time interval by integrating the whole equation. In this slide, I will explain on how to find the total amount of the drug absorbed into the bloodstream over a given time interval by using the equation R equals to 3m squared over m cubed plus 1. Say this drug was prescribed as a 4 mg dosage and U represent m cubed plus 1. I will get the equation integrate 3m squared over U du. And then I will get the answer to be ln U, and by substituting 4 mg into the equation, I will then finally get the answer to be 4.174 total milligram of drug being absorbed into the body. And that's it for our video.